I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. And we are doing a special Tech Field Day event with Intel, coinciding with their How Wonderful Gets Done 2021 event, which saw the launch of the third generation Xeon Scalable processors, commonly called Ice Lake. Now, during this presentation, one of the topics I think that we have been going round and round and round is the topic of edge computing. And essentially, we all know what data centers are. We all know what data center computing is, and racks of servers and networks and storage and that sort of thing. And most of us now have a pretty good understanding of cloud computing in terms of public clouds and having them have the racks and racks of stuff that we get to use. But what is edge computing really? And does Xeon have a place there? I wonder if we can kick things off just by throwing that out to the group. Who wants to start, who has some kind of concept of what edge computing might be?
I'd love to kick us off, Stephen. I'm actually working right now on a pair of reports that were just published on edge platforms. And so it took kind of a deep dive into this. And that was one of the first questions that really had to be answered was, what is edge? Because even though we've been talking about it for a few years throughout the industry in different places, I don't think there's a very clear answer. And it's just like, it reminds me a lot of, 5 to 10 years ago when you said, automation or software-defined networking. And if you asked 11 engineers what that meant to them, you got 12 different answers. And I feel like edge is really in that place now in the infrastructure space. And so, from my perspective, there's a little bit of a taxonomy here. And one is there's really two kind of big buckets of edge, in my opinion. One is device edge, which is really like talking about cell phones, laptops, tablets, IoT devices, right? Actual sensors sometimes, although that may be a little too deep, right? And that's where even there's a little bit of variance in what you might call the device edge. And then there's the infrastructure edge, which is, more like potentially a container at a military deployment or a cell tower in more traditional environments and things like this, where you're actually pushing, real compute power and storage and things like that out to the edge. And then even within that, I think there's actually a few different layers, right? Which is, okay, so you have these two kind of locations of the edge, but then what does edge mean in terms of, are you talking about an application that needs to run at the edge? Or are you talking about the platform that application needs to run on? Are you talking about the core systems that are actually supporting the edge, or the actual physical infrastructure below that, right? So are you talking about a wire and a server? Or are you talking about a hypervisor? Or are you talking, up and up? So it's kind of a stack and then locations. And that's the way I look at it. And from an enterprise perspective, the edge is really where you need your applications to run to give you the right latency for that application.
Yeah, I do think that the word edge actually is coming from the network side of the house. From me, I see edge not as a constant definition, but more as something that varies over time. And the idea there is that once upon a time, most of the heavy-duty computing and processing was done in a centralized area, and the edge was then kind of the smaller workloads, or like Chris was talking about, IoTs, the sensors. I think today, with the distributed model, edge is a lot more powerful and contains more of the similar words you would use in a centralized environment, words like training and inference, right? Training is really lots of data, lots of processing, which typically is not something that would come to mind a few years ago when you talk about edge. Edge was more the inference piece where you run a lightweight application, or maybe even less than that, as a sensor, and then you feed the data back to the centralized environment. So I do think that definitely the definition is confusing. When you look at the self-driving car people, they would define a car as the edge, but their car is filled with compute infrastructure, right? And probably more powerful than some people have in their lab. So from that perspective, I think edge can be confusing. But from a definition perspective, I do think that more and more it will become a common word. With, like Chris said, many people will have different definitions, but nevertheless, I think in general it means distributed versus centralized.
And there's a connection between 5G and the edge as well. And I think that this is an important thing to keep in mind. So, 5G isn't just about faster networking. It's about distributed data center and distributing hardware and compute resources literally all over the globe. So given this definition of edge, and given what we've learned about the Xeon Scalable CPU platform, do we see that this is a good target for Intel to be going after with these Xeon CPUs?
Yeah, I do think that the processor delivers some interesting features and capabilities. If you want a small form factor server up and running, then using and reusing your existing code, which is an important piece, right? I can't hammer enough on that being able to use AI and ML with your existing code without having to recode it into GPUs or FPGAs is a big key factor. So I do think that it's important and brings kind of a workhorse to the edge, or at least to the smaller server environment.
One of the challenges with edge is just, it's less about the definition and more about just what you're doing. But there is variability to it. If you talk about 5G, are you talking about the mobile device, and that's the edge? Are you talking about the micro data center that sits at the base of the cell tower, and that's the edge? Are you talking about the data center that it connects to as an intermediate point along this continuum? Is that the edge? I think it gets really confusing when you try and create this very structured definition of what edge is, and focus more on, and I think it's more important to focus on where's the value and how is the value different at these different points of the continuum. And then it becomes more practical of a conversation too, to say, okay, well, here's how that mobile app kind of comes into play, or where 5G kind of fits into play, or where you can leverage those data centers, those micro data centers at the base of the cell tower, as opposed to just kind of getting, some even going so far as to kind of getting wrapped around the axle on definitions. No, Chris, your definition is wrong. Mine's right. And, Frederick, you're actually right about this piece and I'm wrong about this piece. I mean, I don't think that's as helpful as opposed to talking about how you use them and the value you get from it.
I think that's a really good distinction, Tim. And especially because I think, one example there, right, is I think, a lot of folks, at least, in folks in the circles I run in a few years ago, were really getting excited about edge data centers and edge co-location because we were going to have all these self-driving cars that needed, storage facilities right there along the highways. And they were going to have all this storage that was right there and within, nanoseconds of latency so that driving decisions could be made. And what happened is we put those servers in the cars instead. And made the edge that, we moved the edge into the car itself. And so I think you're right that just like everything else, right? Just like the adoption of cloud or anything else, if you're going down that edge path, you really need to understand what your actual requirements are, what your objectives are, and then build a solution and not try to build an edge solution, so to speak.
It kind of reminds me of the cloud world when we were all talking about, what this sort of ideal cloud is. And now here we are, 10 years later, and the cloud is as varied as the data center, and I guess the edge is going to be as varied as the data center as well. It could be almost anything. But given these workloads, I think that we can all agree that there's going to be more data processing, as Frederick was bringing up, the idea of doing more AI processing, and even some of the heavy-duty AI processing happening in these edge data centers instead of in the core cloud data centers or the enterprise data centers.
And also, let's not forget that we are just at the dawn of this technology and its application. and the speed at which the manufacturing processes they improve is tremendous. So even if we were debating about the feasibility, the usability of Xeon processors in the edge, of course it cannot be used everywhere in all the environments, in all the application, because of size, because of power consumption, because of cooling, etc., etc. But just think about something that can happen in a matter of 2 or 3 years when the same capabilities, the same power can be shrunk into a much smaller form factor with this kind of power that can be applied to much smaller devices, portable ones, or so we're just guessing, but the future is totally to be written here.
This is where I kind of think that, when you look at what Intel has and what they've recently announced, if you're looking to take advantage of some of those features, you can do it to a point and in certain scenarios, but you can't do it in every scenario, nor would you. And so I think it's important to kind of distinguish between that as to where, for example, if you're thinking about a Xenon processor, even in its smallest form factor, you're not going to see that in an edge like a sensor or a camera. But yet, there might be other solutions that kind of fit out of their portfolio into those use cases. And so I think it's important to understand, how do you tie these different components together and take advantage of them where appropriate? Because the reality is, most enterprises are going to have to figure out how to use different components along that edge to cloud continuum, and think about how the data transits across that continuum and how the applications tie across that continuum. And so I always look at it from the top down as opposed to bottom up. And when I start there, I start to see how, like 5G, for example, I was just in a conversation yesterday about this, where there were some theoretical conversations around 5G, but the reality is it's not widely used. And why is it not widely used? And I think it's important to distinguish where it can be used today and in what time scale it might be appropriate for enterprises, or use cases it might be appropriate for enterprises to think about that.
Yeah, I was going to say that we're talking about Xeon and edge. I think what people are looking for is more a solution, right? I mean, it used to be that people really cared about a specific piece of hardware, really wanted it in their environment. I think it almost becomes irrelevant if you look at what Intel is doing with NUC. I'm not sure if you're aware that a lot of third parties are actually ruggedizing a NUC and putting it all over the world as a way to build an all-in-one kind of a solution, right? The counterpart there is also Raspberry Pi, and there's so many out there, and I think if you look at the Xeon portfolio together with Optane and the networking, I think that by itself in a box makes a lot more sense than having 40 cores versus 20 cores, or even a performance increase left or right. I think that's really where the market is going to, and if there are solutions like an enterprise NUC or even a rack server, based on all the different components, the new components, I believe that is more of a dominant piece than anything else.
I can totally see Intel NUC built for industrial edge application coming up in 3-4 years with a generation 4 Xeon that is basically a powered up, scaled down version, lower consumption version of the ones that have been just presented. So it's going to be exciting. And if anybody can do that, anyone can do that, is Intel.
Yeah, and that reminds me of, one of the things that I don't think Intel talks enough about. They did a pretty good job this week in the announcements, but was one API, right? Because I think that's what ties together a lot of these platforms. I know in I think one of the back channels we were talking about, earlier today, Stephen pointed out that there's, multiple different Xeons. Even across the SKUs, there's the Xeon SP, which is what we were talking about today. which is the new third generation Xeon for servers. There's Xeon E, which goes into desktops and laptops and things like that. There's the Xeon D and Xeon T, which I think actually do go into embedded devices and other kind of appliances and things like that. So, and then being able to write code, to Frederick's point, across all of those and not really care where the application runs because you've got this API in any Intel processor, becomes a pretty powerful platform. And I think that's really where, maybe they didn't quite describe it this way, but to me, that's where the edge to cloud story really comes in, which is that you can have these processors across all these different devices. Assuming they have the capabilities you need, you can write code that works on any of them.
Right. I mean, you bring up a good point with the software, right? The software really defines what you can do with the hardware. It's not because you have a fast processor that you're going to get faster and better results. It's the software stack, and I do think that Intel doesn't focus enough on that all the work they're doing in the background regarding to software. They could actually deliver a box like a NUC with the complete software stack for MLDL. I don't think there's anything they need from anybody else in order to do that. They contribute enough on the hardware and the software side to be a full-blown player. And I also do think that buying the biggest and the meanest server is also kind of outdated. You still need for bigger servers for workloads that require a lot of memory, but you can see it today. The way application development is going is you just put multiple smaller blocks together, and that's how you balance and distribute your work, as opposed to just getting a big server and run everything on that single server.
Instead of buying a big honking server, you buy multiple servers and distribute your workload, right?
Yeah, micro servers for distributed microservices.
Right, and it's not only about the microservice and the service, but it's also, think about it. If you have a cluster with 100 of those servers, and there's new technology you want to introduce, you can start replacing one by one those components, those NUCs, if you wish, by a newer version, and you're never down, right? You're always up and running. There's a level of abstraction. If there are new features, you will automatically use them. So it makes it a lot easier. You don't have to worry anymore about, what hardware do I have underneath. If you're taking advantage of a new instruction set, then the tools will do that for you. You don't have to worry about that. And I think that's really the future. I don't see a lot of people anymore kind of puzzling components together and say, I need to have the best of each one. I just don't see that anymore. A lot of people understand that flexibility from a software perspective is a lot more important. Look at how applications used to be developed. They were spending tremendous of time developing C++ applications, and the fastest runtime. Tools like Python and Perl were kind of considered, it's nice for prototyping, but not for production. While nowadays, it's completely different. It's all about the flexibility. People realize that developing C code is very time consuming and not as flexible as writing Python code. And Python is definitely slower than C code, but the flexibility brings a lot more to the table. And I think the same abstraction kind of counts for hardware.
Well, I think we've kind of reached the conclusion then. So it seems that this is in keeping with the disaggregation of the data center, with the growing use of, if not edge in terms of clients, but edge in terms of distributed data centers, and that there's a place for Xeon in this future architecture.